Hi, this is Miss Litton, and this is a very teeny tiny review with two wonderful young ladies here. That's why this review is getting recorded. I don't know where the rest of you are, other than your quiz isn't until Friday, so you're not thinking about it. But this is for the nervous system for honors bio. And a couple of things you want to make sure you can differentiate between is the central and the peripheral nervous system. Central nervous system is the brain and the spinal cord, and the peripheral nervous system is everything outside of that. Neurons are the functional units of the nervous system, and sensory neurons head towards the central nervous system. They're sensing something and bringing that information to the central nervous system, and motor neurons go away from the central nervous system. And in between sensory and motor neurons, you remember what they are? Those are interneurons. And your brain and spinal cord consist of interneurons. Then you can see there's this motor neurons go to effectors, and there are only two kinds of effectors. There are muscles and there are glands. Those are the only two kinds of effectors. However, when you talk about your somatic nervous system, these are going to skeletal muscles, and this is about choice. And when you go to smooth muscle and gland, that's part of your autonomic nervous system, things you don't need to think about. The autonomic nervous system is broken into two parts, and I'll just tell you, sympathetic and parasympathetic. So sympathetic is when you're under stress, like fight or flight, and parasympathetic is normal. And the way I remember that is I have sympathy for somebody who's under stress, or you can think about it, parasympathetic is a longer word, so it's slower, something along those lines. All right? And so we looked at the different kinds of neurons. This is a motor neuron going towards an effector, in this case a skeletal muscle. This is a sensory neuron going away, and then an interneuron is in between. As far as your peripheral nervous system, those neurons are often have what's called a myelin sheath on it, and that helps insulate the neuron and makes the conduction go faster because it can skip from each gap, which is called the node of Rambier. And if you remember when we learned about setting up the resting potential and the sodium-potassium pump, it only has to worry about the regions right here keeping that resting potential, because that's the only active part of the neuron. So it takes less energy if you're just charging those gaps, and the fix is a lot faster. Okay, we looked at this, if there was a tack right here. It's a terrible tack. There you go, pointy. Sensory neuron going towards the central nervous system. This would be an interneuron, part of your brain or spinal cord, and then a response via a motor neuron. And then we did those reviews, so now let's go over here. How does a neuron fire? And you want to remember the purpose of a neuron. You're trying to get information from point A to point B. So if it starts with a stimulus of some sort, like that tack, I need to communicate from my foot all the way up to my brain, hey, move your foot because you're stepping on a tack. So to get that information from my foot to my brain, I'm going to use a neuron. And the length of the neuron, it's an electrical message. And then at the end of the neuron, it is a chemical message. Are you coming for the review?
No, about the quiz.
Oh, okay.
Yeah.
Which quizzes that you wanted to take?
No, can I take it during my zero period class on Thursday?
Well, we'll be doing the fetal pig then, so we probably won't have time to do it, but you could do it on Friday, maybe?
Okay, yeah.
Okay, so Friday.
Yeah.
Okay, so there's a chemical message at the end. So we talked about there were 3 ways to set up the resting potential, because when a neuron is at rest, when the neuron is at rest, the outside is positive and the inside is negative. Good. So the 3 things were the sodium, potassium, what? Pump? That's okay. It's okay. Which pumps 3 sodiums out for every 2 potassiums in. So that means there's more positives outside than inside. Okay, so that's one part. And then the second part is the negatively charged ions and proteins. Okay, so not only do we have more positive charges outside, we have more negative charges inside. And then the third thing is the leaky potassium gates. Potassium tends to leak back out. So this sets up the resting potential when a neuron isn't firing. So the outside is positive and the inside is negative. To make a neuron fire, this will happen with a stimulus. So I have some sort of stimulus right up here, bathing the dendrites of this neuron. So I want to convey and get that information to the other end of the neuron. What happens is the sodium gates start to open up and sodium moves into the neuron. And if it reaches the threshold, that's not right. Okay, remember it's about minus 65, minus 70 millivolts inside. And if we can bring it to like minus 40, minus 35 millivolts, that will trigger an action potential. And then all the sodium gates in sequence. This will trigger the next gate to open, which will trigger the next gate, and the next gate, and the next gate. And that is the action potential. Where now the positives have come inside, so the inside is positive relative to the outside that is what? Negative. Yeah, because all those positive charges. And once those positive charges come in, then at the other end, and we learned this already, so I'll go ahead and talk about it now. It's sodium coming in all the way up to the end, and then a new substance comes in. Calcium. Good job. So calcium comes in, and that causes these synaptic vesicles to migrate to this presynaptic membrane right here, releasing some sort of neurotransmitter out into the cleft. Okay? And it can cross the cleft and land on the postsynaptic membrane, and if it's excitatory, it can trigger an action potential in the next neuron. So electrical along here and then chemical. But see, now our neuron is fired. We might want to fire that neuron again. So we need to reset the neuron so that it's positive on the outside again and negative on the inside. So there's the quick way to restore it. Do you remember the quick way to restore it? Potassium goes out and takes sodium's place outside. Okay? That's the quick fix. The long-term fix, gentlemen, is putting sodium back outside and potassium back inside, using the sodium-potassium pump again to reset your resting potential. But the really fast fix is sodium just came in along the length of the neuron. Potassium goes out, 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 out. Right away, as soon as the neuron fires. It's like literally the sodium's going in and right behind it the potassium's going out. Okay? And that is your action potential, is when the sodium comes in. Restoring the resting potential is doing the potassium going out, and the long-term fix is sodium-potassium pump. When we look at this diagram, if we said what's happening at A, what's happening at B, what's happening at C, what's happening at D, what's happening at E. So we have 5 different things here. Okay, 3, I don't know how to count. At A, we have our resting potential. How was that established? You already told me. What were those 3 ways to set up this resting potential of minus 65, minus 70 millivolts? What? Sodium potassium pump, pumping sodium out, potassium in, the negatively charged ions and proteins, and then potassium leaking back out. That sets up your resting potential of minus 65. Okay? What's happening at B to make it less negative?
When the Na is
Exactly. This is when sodium comes in. And then here, now the outside is no longer negative, the outside is positive because you've had a reversal of charge. Okay? What's happening at D?
Is it when the K?
Exactly. Okay? K goes out to take sodium's place. Okay? And so that's what's causing it. When it goes out, it's making the inside more negative, right? Because it's a positive thing going out. And then here, this is that refractory period. Those potassium gates allowing potassium to go out are open a little bit longer than the gates to let sodium come in. So a little more positive charge goes out than ever comes in. So as a result, you kind of get this hypernegativity right here, this refractory period, and this keeps the signal going in one direction. All right. Then we talked about what happens. Here is a neuron, and there are several different neurons. These are all synapses. Some of them can be excitatory, some can be inhibitory. You could have, 10,000 different synapses on a neuron. And so what we're looking at is we're looking at one of these axonal bulbs when we look at this picture. So here's one of those axonal bulbs. And all along, sodium was coming in, and potassium's going out to restore it. But here at the axon, you told me, at the end of the axon, at the axonal bulb, what comes in instead?
Calcium.
Yep, calcium comes in. Synaptic vesicle then fuses. This is the pre-synaptic membrane. This is the post-synaptic membrane. And so the synaptic vesicles fuse. Neurotransmitter crosses the cleft. It will bind to a receptor on, this is the postsynaptic neuron over here. And then this opens up this gate. And if this is excitatory, sodium comes in. And if enough sodium comes in, it'll reach the threshold and trigger another action potential. Right? And here are the steps of that. And you probably have those steps written in your notes, right? Okay. All right, and then that postsynaptic neuron has to add up all the excitatory and inhibitory messages to come up with its overall response. In this case, its overall response didn't reach the threshold, so this neuron would not fire. And it wouldn't have fired even if there wasn't an inhibitory message. It still wouldn't have fired because the excitatory message didn't reach the threshold. Okay, and then that brought us here to our vertebrate nervous system. We talked about this was a really good picture. So we have the central nervous system is brain and spinal cord. Peripheral is everything outside of it. We have 31 pairs of spinal nerves, and they are all mixed nerves, which means they have both sensory fibers going in and motor fibers going out. The cranial, you have 12 pairs. Some are sensory, some are motor, and some are mixed. Okay, so it's showing you sensory and motor here. Now, you have your somatic nervous system. If I picked one word to summarize somatic nervous system, I would pick choice. Because I'm choosing to move my skeletal muscles. If I picked one word for autonomic, I would probably, what could you pick? You don't have to think about it. I could say it's automatic, good. And I could be having to speed up, sympathetic. Okay, this is one word, stress, I would say. Any kind of stress. Stress because you're working out, stress because you're running, stress because you're taking a test. Whereas if I picked one word for parasympathetic, any guesses what I'm going to put? This is your normal, this is your relaxed. Like, you know you're not taking a quiz right now. So your parasympathetic nerves are allowing your food to digest. And so that's where you're focusing your energy. If somebody came in here and said, I'm going to beat you with a bat, okay, and you're like, ah, and you started running away, then you're going to stop with your parasympathetic, and it's going to be more about your sympathetic. In fact, when you're done and the scare is over, you might throw up because you left all that food undigested in your gut, not moving. All right, then we looked at brain and central nervous system. The brain and spinal cord are part of your central nervous system. There are three things that protect it. You have membranes that will protect it. You also have bones that protect it. And you also have cerebral spinal fluid that all protect your central nervous system. When we look at it, we can see gray matter and we can see white matter. White matter is white because it has some myelin sheath on it. Gray matter is gray because it's unmyelinated neurons. You can see that here. Gray matter and white matter. A sensory neuron comes in the back of the spinal cord. Its cell body is out here somewhere. There is an interneuron in the spinal cord. Then there is a motor neuron going out the front of your spinal cord. And gray matter is areas where they can make connections because they have no myelin sheath. we can see the spinal cord here, and these are mixed nerves. Sensory neurons are going in the back, and then the motor fibers are going out the front. And that's why you can see like a two-way street here, a mixed nerve. It has both. And here on our brain, okay, on the parts of the brain that you need to know, here, let me get a cross section. You want to think about this area right here, which is your cerebrum. And this is memory, learning, thought, thinking, processing. You have your hypothalamus right here that controls your pituitary gland, and we've already studied that connection. That's a link between the nervous and the endocrine system. Above it is the thalamus, so this is the hypo below the thalamus. And the thalamus is connecting memories and smells. You have your cerebellum, and we think of Sarah the ballerina, helping with balance and muscle tone. Right here you have your midbrain, you have your pons, your medulla oblongata, and we know about our medulla oblongata, that's what? Heart rate, breathing rate. Our spinal cord is all about the reflex. This is balance. This is heart rate and breathing rate. So when you think of your reflexes, think about your spinal cord. And then this is just showing you the connection. The big word here on hypothalamus is all about homeostasis, and it is the link to the nervous system. Cerebellum and balance. We talked about this area right here. We can't live without that, and that's good because it's deep in our brain. So we could have damage and a chunk out of our cerebrum. Maybe we wouldn't be as bright or be able to speak very well, but our heart would still beat. And then we went into limbic system. This is about setting memories or emotion, part of your lizard brain. And I always tell you, be in your mammal brain, because this is about food and sex and desire, some learning in there. And this is not on your quiz, but reticular, wake up and pay attention. Peripheral nervous system, everything outside your brain and spinal cord. We've talked about that already in the mixed nerves of your spinal cord. This is a good diagram. Okay, because you know your central is your brain and your spinal cord. Your peripheral is outside, somatic, about choice. Autonomic, I think automatic. Sympathetic is about stress, and this is relax. So if I said to you, parasympathetic nerves, is it central or peripheral? Yeah, it's peripheral because it's nerves. It's outside of your brain and spinal cord. So that would be peripheral. And then if I said, is it somatic or autonomic, you would say autonomic. You don't have to think about it. Okay? And then if I said, and then parasympathetic would be about relaxing. And so it could be things like digestion, you know? Whereas if I said sympathetic, that would be more along the lines of stress, something stressful. Right? And then reflex. So you sense it, synapse with an inner neuron, synapse with a motor neuron, so that you can respond. Okay, and then the last thing was about drugs, don't do them. But drugs, and you've studied the endocrine system as well. So oftentimes drugs act as neurotransmitters or hormones from our endocrine system, and they interfere with the synapse, either cause you to release too much chemical or not be able to uptake it or block the receptors for it. And then in general, you would want to know the definition of addiction, you know, where you're dependent upon that drug just to feel normal. And things like alcohol is a depressant, cigarettes are stimulants, and meth, anything that's cooked, a designer drug, spice, K2, all of those, there's not gonna, when somebody is concocting something, chemically mixing something, they could put some sort of toxin that's in that accidentally, which could harm you. Don't do heroin. Initially it causes euphoria, but later you take it just so you don't feel the withdrawal symptoms. And what else did I have in here? Yeah, don't do spice, and don't abuse drugs, and talk to somebody if you need to. Okay. That was it. Are there any questions? Okay, good job, you guys. It's 20 minutes of nervous system. Have a piece of toast. Should have come to this review.